Hi, my name is Aryan, and here I want to briefly overview our recent research on spatial analysis of shared e-scooter trips published in Journal of Transport Geography. Micromobility emerged as a component of transportation system in modern cities in recent years. Since this mode is relatively new, there is a lot to know about the association of e-scooters and demographical and environmental factors. This figure shows the framework has considered in our study. We focused on factors affecting density of e-scooter trips in 6 main groups, including demographics, population density, diversity, design, distance to transit, and urbanism scores. In order to analysis, we use geographically weighted regression, a spatial analysis method. More than 400,000 e-scooter trips in more than a year of operation analyzed in our study. And the right figure shows the study area and density of e-scooter trips. We started our analysis with checking if spatial independence exists in our case. The global Moran's-I was used to test, and results shows that index is higher than expected index, meaning that the data is clustered. Therefore, we need an approach to account for spatial independence to model e-scooter trips. Because of that, we use GWR for our analysis. Here you can see the results of local Moran's-I. Local Moran's-I gives insight into how the density of e-scooter trips locally are different. The results show low clusters in West End, Syracuse Park, and St. Matthews area, and high clusters in downtown, Old Louisville, and University of Louisville area. GWR method was used for analysis in which coefficients vary spatially using MGWR software. Here you can see the significant factors based on GWR results. According to the results, all the factors had the positive impact, but the magnitude varies in different TAZs. Here, I want to go over 4 of them to see the impact more in detail. In this slide, the upper figure shows the percentage of individuals between 18 to 29 years old, and the other one shows the percentage of male impact. Male percentage result indicates a gender gap in e-scooter usage. Here you can see the impact of walk score and park score on e-scooter trips. A strong positive relationship between walk score and e-scooter trip density. In fact, walk score was the only factor that was significant across whole study area. And about park score, the significance may be due to use of e-scooters for recreational purposes rather than a mode of transportation. This table shows how accounting for spatial independence improves GWR results comparing global ordinary least square. This figure shows how goodness of fit especially changed across the study area, moving from the east of the study area toward the west. Generally, the goodness of fit in the GWR model was increased. In summary, in this study, the factors influencing e-scooter trips in Louisville, Kentucky were investigated using GWR. The results emphasize that the relationship between the studied factors and e-scooter trips varies spatially. There are some limitations that I would like to mention here. While GWR was employed for the analysis, there are likely unobserved latent factors contributing to the variance in estimates of coefficients. Another issue that was taken into account was the edge effects. This effect originates from the interaction between the zones outside the study area and the zones within the study area. The zones outside the study area are relatively sparse in terms of e-scooter trips due to numerous reasons related to land use, trip characteristics, and e-scooter deployment. Additionally, many of the zones close to the edge of the study area fall along a natural barrier due to presence of Ohio River. Another issue is the distribution pattern. Distribution pattern would significantly affect the density of e-scooter trips in each zone. However, because each distributor would come up with the best plan to maximize its profit, this issue may not have a considerable effect on the results. Thank you for your attention. Please follow us on social media and check out our website for the new updates.